let's check how you were doing. And I know some people are still finishing up, but we got a big jump into this earlier. I was walking around and I saw a lot of correct answers on the first one, but I just want to make sure that we all have the correct answer on there. Plugging in -5. A lot of it has to do with the recognizing the positive negative things going on here. -5 squared is 25. Negative times a negative is a positive 10. Adding all of those together, we get, let's see, 3542 for that first answer. Plugging in our binomial, again, I will highlight the places that we tend to make mistakes. If I put in, again, a parentheses everywhere that there was an x and then go back and fill that in, I was supposed to be plugging in an x plus 4. So x plus 4 here, x plus 4 here. Write it twice in FOIL when we have that. So from that first term, I should have gotten an x squared plus 8x plus 16. And the next common mistake, the first one would be that we just squared that and got the x squared plus 16 and we forget the middle term. The next most common missed thing would be distributing the negative with the 2. It is a -2 that you are distributing through there, so if you did not, your constant will be incorrect because you would have added 8 instead of subtracting, so we should have a -2x minus 8. Combining our like terms then should give us x squared. Add our like terms, 8 minus 2 is 6x. 16 minus 8 is 8, plus 7 is 15. Any questions on that? So forgetting to distribute a negative all the way through is probably the second most common mistake after forgetting to FOIL. And your last one, plugging in that -x. And again, the negative squared gives us a positive x squared. Negative times a negative is a positive, 2x plus 7, and there is nothing else to simplify about that. Any questions on that? All right. Moving on. On this next one, for your notes-taking purposes, let me highlight the important places that you can just connect with straight lines. If I make this a little bit bigger for us here. The first, it starts over here on the farthest left down here at -2, 0. And then we go through the y-axis at 1, and there's just a straight line connecting those 2 points. And then the last point is up here at 1, 3, and a straight line connecting those 2 points. Okay. Now, for whatever reason, it is consistently one of the things that can really trip people up if you don't understand what is being asked of you in these problems. To evaluate a function given a picture, and a lot of times people are like, well, what's the function? What's f of x? Where am I supposed to be plugging this in? Guys, you don't get anything other than a picture, and you have to gather the answer from the picture. So there is no function to go plug it into like we just did on the last page. What you are doing is you're trying to identify where that dot is on the picture. Remember that in function notation, it is f of the letter x, and in an ordered pair, that's the first number in your ordered pair. And what we're trying to do is finish that ordered pair specific to this picture. So specific to that little blue line, it would be the ordered pair x comma whatever, or -2 comma something, and that something then becomes our answer. So go to that x value, scan up and down that vertical line of that x value until you run into the graph. And wherever you can put that dot on the graph that has that x value that they handed us, that's how you answer the question. Okay, so -2 is over here. I would scan up and down -2 until I ran into my graph, which I didn't have to go far. It was right there at -2 comma 0. So your answer is 0. This is your ordered pair, -2 comma 0. Specific to the blue line that they give us. There is no function for me to go plug it into. It's purely looking at the picture and finishing the ordered pair. Okay, so let's try that again. My next one, again, it's like 0 comma something, and I get that something from my picture. So I go 0 right or left, and then I find my graph along that line. So here's 0 right or left, right? This is where x equals 0. And to get up to my graph, I would come up here and I could put a dot on my graph and finish the ordered pair 0, 1. Now we don't write it like an ordered pair like that, but just kind of helps you with where that's coming from. Remember, it's just finishing the ordered pair specific to our picture. Okay, so the last one, 1 comma. So again, go over to where we would go to the right one. Well, to get onto our graph, we would have to go all the way up here, and it would be 1, 3. Now, they can give you the second part of the ordered pair first instead of the first part in something like this next question. For approximately what value of x does f of x equal 2? So really the question is something comma 2 is in this picture. And you kind of have to look at it the other way around. Where on this graph would my y value be up at 2? So here's a y value of 2 would be along this line, and you just kind of see where that runs into our graph, right? That's where y equals 2. And somewhere along here our graph hits. Well, that would be right here. The answer is, what is the x value for that ordered pair? Because that ordered pair is something comma up 2. So it looks like I had to go to the right. I don't know, it's approximate. So halfway between 0 and 1 maybe. Okay. So I went to the right a half up 2 to finish that ordered pair, or x equals a half. So when they're asking you to look at the graph, again, there is no function they will hand you. The function is the picture, and you are just finding the dots along that line that help you fill in those ordered pairs. Any questions on that? And when you start making that connection, these become pretty easy. There is no work to do. They're pretty straightforward questions, but I get that it is confusing when you're looking for a function to go plug it into, right? Because we're used to this. There is no function to plug it into. Okay, now, this is about the last time that I'm going to ask you to do this, and that is making a table to graph your function. We are transitioning away from this. You are going to be the level of math student that can look at an equation and via transformations graph me a picture of that function. So not very many more times are we going to do this. But I do want to talk about the directions a little bit. It says graph the function of f of x equals 2x and g of x equals 2x plus 4. And then I use this phrase, in the same rectangular coordinate system. Guys, the in the same rectangular coordinate system is a fancy way for saying on the same graph. Okay? Use the same graph, draw both of them. And then it does tell you what x is to use. Select integers for x starting with -2 and ending with 2. Okay? And that is how they knew what numbers to put into the x column of your table. With that being said, I feel like we are at the point where you can have a little bit of creative license with your table. If you liked this because you are a person that likes to see your work and plugging it in, please stick with this format where you do the x's, showing my work, ordered pair, have at, okay? So I would show 2 times -2 equals -4, making my ordered pair -2, -4. If you don't necessarily love this setup of the table, you are welcome to streamline it a little bit and go with input and output columns. So I could go like -2, etc. here, and f of x here, and if I plug -2 into f of x, I get -4, and there's my ordered pair, -2, -4. So if you like the little bit more streamlined table, you are welcome to utilize that. Again, we are going to be done with tables here pretty soon. Until we start talking transformations a little bit, we'll utilize them a little bit. But pick your poison, make your tables, graph both on the same thing there. Again, we're just trying to preview into transformations and what that is going to mean as far as seeing those things happening. They're going to continue to ask you, how are they related? So you can start recognizing, oh, this number showed up here, and that's what it seems to always be doing to my graph type of thing. Okay, so take a second and draw those two graphs for me, please. Those of you that remember, you can also utilize things like your table on your calculator if you remember how to do that. Would also help speed up your process a lot on this. For our notes, I will continue to fill in this large table. And then we're going to graph those ordered pairs. So now I'm going to go over to my graph, and I'm going to graph those ordered pairs, and then I will do the second one and put it on the same graph. so you know the difference between the two. Typically they start at F, and if there's a second one they'll go to G. Usually after that it's H. Y right there in the middle of the alphabet. I mean, I can figure out why F, but I don't know why the others. But yeah, that's just to distinguish it. Okay. To describe the graph, guys, that is, you don't have to get like super technical or like write a lot. It's very real world speak here. I mean, look at like when I plugged in 0, what's the difference in my answers? I got a 0 and I got a 4, and I could compare that same difference for all of these. Is that G was 4 higher than F was, right? They're the same line, but G has moved up 4. That's all it is. Okay, so anything indicating the fact that we moved the first one up, they were the same shape, whatever, but moved up 4. Any questions on that? Again, utilize your resources. If you want to go to your table on your calculator, you remember how to type this into Y1 and Y2 and look at your table. It'll do all of that for you. But make sure that you can graph all of those, etc. Okay. Now I do want you to use your calculator. If you will go grab your calculator, I want you to put these into Y1 and Y2, look at the pictures, and think about how you would describe what you notice in your pictures. Now, here's my little helpful advice. If you are a color calculator person, you can just go type this into Y1 and Y2 because they are color-coded for you, and it's easy to tell which one is which. But if you have a black and white calculator, sometimes it's hard to see which one goes to where. So my real world advice would be type in the first one, go glance at the graph so you can see where that first one ended up, and then you can go type in the second one so you can tell which one was the first graph and which one was the second graph, so you know what's going on with those. Let me see if I can switch my share here to my calculator. Why is my calculator not showing up? There it is. Okay. So I did that, and again, I have that color calculator, so it's easy for me to type those in. Just a reminder about when I am asking you to show me things that you are doing on your calculator, is that if I go here to draw a picture of what I just saw, I do need to have that X and Y axis in there. My first graph was moved here, it looks like, and my second graph, notice I don't have tick marks or anything on here, but I'm getting them in approximately the correct location on there. What did I notice? Well, the blue graph was the first one I typed in, and looking at those numbers and what I see, I would say that this one, the first one was moved down to. And my second graph, again, comparing it here, and what I see, it tells me kind of how far it went. So the second graph moved, and it looks like it moved right, 3. okay? And that's, again, all I kind of have to write about what I notice on these things. Any questions here? Okay. The last little section we're going to look at is the same types of questions I was asking you earlier about looking at a graph, but looking at a real-world data type of graph. And when you guys are looking at real-world data type of graphs, one of the big things I want you guys to make sure you look at is the labeling on your x and y axis, okay? What does the variable represent? What does the function represent? And how would I label those? The one we are looking at here is out of your book. It says the average progress of the HIV disease is the average number of T cells is the function over time after the infection is your X value. So those of you who don't know much about the HIV disease, it is, starts attacking these cells in your body that get rid of infection, and those are called your T cells. And so tracking the number of T cells is always a big thing when they're talking about the HIV disease, and that's what we're looking at here. Notice that a healthy adult here at a time of infection compared to when they get diagnosed with AIDS means your T cells have dropped below a certain level, down to you can't stop an infection in your body type of thing. So our labeling on here says time, and it says time after infection in years, and so that's what these numbers are representing. And moving up this direction, says the average T cell count in per milliliters of blood. So this is our T cell count, okay? And this is, again, your function, your y or your f of x, right, is your function, what we would label that answer. This is what you would be plugging in, or your just plain old x values. So it says, explain why f represents a graph of a function. Now, this question, for whatever reason, is always, you think it is a trickier question than it is. I want you to think about what you would answer for that real quick. Don't say anything out loud. Just think about if I had put that down in front of you and you were looking at this picture, explain why f represents the graph of a function. I want you to think about what you would write down for that. Okay, last Friday we talked about deciding if something was a function. If we had ordered pairs to look at, we just made sure that all the x's were unique. We didn't have any duplicate x's. If we were looking at an equation, we made sure that it wasn't a y squared. That made it not a function. If we were looking at a picture, and we are looking at a picture, we used our vertical line test. And so to explain why this is a function, it passes the vertical line test, okay? Has nothing to do with the situation at all. I don't have to talk about the years. I don't have to talk about the T cell, nothing. It passes the vertical line test. Okay, so I know people want to think about specific to this, but no, function. Why is it a function? Did the x's repeat? Was there a y squared? Did it fail the vertical line test? Any of those things would make it not a function. Now the next part is, guys, I want you to make sure that this is something you become very good at, is that you're understanding. I don't want you to look at a graph and be able to just tell me, oh, it's 8 comma something, because we now know that that's what that means when we look at a graph. But real world, okay, real world speak. If I'm looking at this and it asks me to do f of 8 and interpreting those values, okay, we know that when the question is to find this, that we're really thinking what 8 comma something from our picture, right? And we're going to answer the question, what is 8 comma something? So if I come over 8 and go up to my graph, it looks like I would land at the dot about here. So how would I answer that first question? 8 comma? 200? It's a 200. Is that the number you were trying to read? It's a 200. 8 comma 200. But that means nothing unless you can tell me what those numbers are representing. Okay, so now if I were to ask you to interpret, this is where we go back to the labeling. 8 what? 8 years. So 8 years after our infection, 200 what? T cells. So interpret. 8 years after infection, the average number of T cells would be 200. Right? You see how we're getting those interpretations? Now, some of you are saying, I don't know how you knew that. Remember how a graph goes, that this is our x-axis and this is our y-axis. So along the x, that is the labeling for the x. Remember it goes x comma y, right? That would be the labeling I would put on that number. So I can just follow that. The x-axis labeling is years, so 8 years after infection, right? And then go down your y column, and that's how I would label any second number in my ordered pair. Average T cell count. So that any number that ever fell into this in our ordered pair would be our average T cell count. Questions on that? Okay, so sticking with this same picture, some different questions. So we saw one like this earlier that had no like meaning behind it, but now we're talking meaning here, and what does it mean? For what value of x is f of x equal to 350? Now this one's kind of hard to see. So we're going to talk about what like appropriate answers would be here. So I want you to look at the picture. For what value of x is f of x equal to 350? What do you think? 7, 6. Yeah. Let me see if I can make this even any bigger. It's tricky to see, especially because 350 is not marked on this picture. 300 is not even marked on this picture. But we go 200 up to 400, so 300 is going to be somewhere in here, which means 350 is going to be somewhere halfway between those two. And if I follow that along until it hits my graph, okay, it's going to hit my graph right here. So that's the y value. The question was approximately what x value. And I don't know how straight my lines are or how well I measured halfway, right? That's why it's approximate. So if you said somewhere around the like 6-year mark, I think you're doing great on that question. Describe in general the trends shown by the graph. So what are we seeing happening over time? Declining, yeah. The math word we would use would be decrease, right? Increasing and constant is kind of the words you use to describe graphs. But absolutely. And when they ask you like to describe the general trend, we don't worry about like little blips like this that, oh yeah, went down and then went up and then went down. Just like if I were to step away and like kind of squint my eyes at it, what in general is happening, and it is decreasing. When deciding on the word decreasing or increasing, you would read it like you would read a sentence or a page from left to right. Okay? Any questions on this? All right. I put this page up here, and hopefully, somebody looks at it and goes, wait, didn't we already discuss y-intercepts and x-intercepts, which we called zeros? We had this discussion already, right? Okay, yes, we did. Hopefully, you may have been like, okay, I already know what those are. Hopefully you do. I just want to point out that we have transitioned away from talking any old relation that you could ever look at out there, including like circles and ellipses and things like that, to now specifically functions. And I'm going to show you the one tiny change between talking about x and y intercepts last week compared to function-specific x and y intercepts. And that's what I have in the blue. X-intercepts, again, typically more often referred to as zeros. You still can have none, one, or many. There is no set number on those, okay, or no maximum number. In fact, I picked this function, passes our vertical line test, right? I picked this function because it has, go along your x-axis, 1, 2, 3, 4, 5, 6 different x-intercepts. All of those would be listed here, -5, -3, all of the x values in which it hits my x-axis. I would again encourage you to avoid writing those as ordered pairs because unfortunately on some of your check for understandings we flipped the 0 and the number, which again makes it not the correct point, right? So I would just list them as numbers. But this is the difference. Y-intercepts for a function specifically, it can have at most one. At most one, okay? In this particular picture, if I go up my y-axis, the y-intercept is up here at 4. Why is that a thing? Because if I had more than one, it fails the vertical line test. That's exactly why. Because if I had a graph that had maybe a y-intercept here and a y-intercept here, maybe it looks like this. I mean, isn't the y-intercept like failing the vertical line test if we have more than one. So a function, now, does it have to have one? It does not, okay? It does not, which is why I say at most one. It could have none, right? So we could say like, or none. What the heck? Sorry. Oh, that was our last slide anyway. Your assignment is here if you need a picture. It'll be on Google Classroom. I do not have the PDF posted because I want you to go to the book website and try that out. I'll put the PDF up later, but not right now. I'm sorry to have run up to the bell right there.